All right, what I want to talk about today is when to use appropriate measures of center based on the shape of the distribution. So I have three basic shapes. The first one is symmetric because my left side looks like my right side, so it's approximately symmetric. The second one, the data is skewed out to the right, so it's called skew right. The third one, the data is skewed out to the left, so skewed left. Two measures of center we're using statistics. The first one is the mean, or we call it the average. It's when you take all the numbers, add them up together, divide by how many that you have. This is the best measure of center because it takes into account every piece of data. The other one's called the median, or the middle. It's where you look at your data set and you find the one or two pieces of data in the middle, and you look at that as a measure of center. It's okay. For which shape, which measure of center is appropriate? To illustrate this, let's look at an illustration. So here's a data set, a little distribution. On this data set, we have a mean, which is a blue line, and we have the median, which is a pink line. This data set is approximately symmetric because the left side looks pretty much like the right side. What you want to notice is the mean and the median are about the same. If that's the case, going back to our which shape, so when we have approximately symmetric, we want to use the mean. Why? Because the mean is the best. And because the distribution, the mean and the median are about the same anyway, so might as well use the best one we can. When we have a skewed distribution, alright, so looking at this distribution, it's pretty symmetric. We're going to make it look skewed. So we're going to do that by moving these data points over here. As I do that, look at my blue line, look at my mean line. It's starting to follow that skewness. And as I have skewness and outliers out here, you notice that blue line follows the skewness, but the median pink line kind of stays in the center. We want to take note of that. That means that the mean is affected by skewness and outliers. The median is resistant to outliers. So I'm going to add that to my notes that the median is the middle number. It's also resistant to skewness and extreme outliers. So resistant to skewness and outliers. Okay? So if that's the case, when we ever have a skewed distribution, we want to use the median as a better measure of center because it's resistant. Let's get a couple examples. The first example, we have a data graph. If I draw kind of a curve over it, if you notice, the left side kind of looks like the right side, so this is approximately symmetric. So we should use the mean. It's the best one we can use, and the mean and the median are going to be about the same, so we're good to go. This one, skewed to the left. So skewed left. Remember, whenever we have skewed distributions, the median is better because it's resistant to skewness. And these outliers. Where the mean, it follows the skewness. All right, that's all. Thanks.